Let's discuss electrical system restoration and the concepts of prayers, good wishes, and positive energy as they relate to this process. When dealing with electrical issues in a home, particularly those that are persistent and difficult to diagnose, it's understandable to seek various forms of support, including those that go beyond the purely technical. The idea of sending prayers, good wishes, and positive energy towards the restoration of an electrical system can be seen as a way to foster a sense of hope, well-being, and confidence in the process. Envisioning a home basking in the glow of uninterrupted electricity is a powerful image. It represents not only the functional aspect of having a reliable electrical supply but also the comfort, convenience, and security that it brings to the occupants. This vision can serve as a source of motivation and encouragement during what can be a stressful and disruptive time. Manifesting a smooth and successful electrical renovation is another key element. Renovations, especially those involving electrical systems, can be complex and unpredictable. Visualizing a positive outcome, where the work is completed efficiently, effectively, and without unexpected problems, can help to create a more optimistic and proactive mindset. The phrase "may the power flow through your circuits with ease and confidence" is a poetic way of expressing the desire for the electrical system to function as it should. It speaks to the underlying principle of electricity as a source of energy that should be readily available and reliable. Channeling collective energy towards a home is a symbolic act of support. It represents the idea that the combined thoughts, intentions, and well wishes of others can have a positive influence on the situation. This can be seen as a way to amplify the positive energy surrounding the restoration process and to create a sense of community and shared purpose. Vibrations of stability, grounding, and electrical harmony are essential concepts in electrical systems. Stability refers to the consistent and reliable supply of electricity. Grounding is a critical safety measure that protects against electrical shock. Electrical harmony represents the balanced and efficient flow of electricity throughout the system. Holding arms up towards a specific location and chanting is a symbolic gesture of sending energy and intention. It's a way to focus collective attention and to amplify the positive vibrations towards the desired outcome. This energy is meant to envelop the home and guide the necessary repairs and renovations to a swift and successful completion. The replacement of a main service panel, such as a Zinsco panel, is a significant undertaking. Zinsco panels are known to have potential safety issues, and replacing them is often recommended to ensure the safety and reliability of the electrical system. Opening, inspecting, and rewiring outlets is another crucial step in restoring an electrical system. This allows for the identification and correction of any potential problems such as loose connections, damaged wiring, or outdated components. Addressing ungrounded outlets and installing ground fault circuit interrupters, or GFCIs, are important safety measures. Ungrounded outlets can pose a risk of electrical shock, and GFCIs provide protection against ground faults, which can also be dangerous. The National Electrical Code, or NEC, provides detailed guidelines for electrical installations and safety. It's important to ensure that all electrical work is performed in accordance with the NEC to minimize the risk of hazards. Understanding basic electrical concepts is helpful in comprehending the issues involved in electrical system restoration. Voltage, measured in volts, is the electrical potential difference that drives the flow of current. Amperage, measured in amps, is the measure of electrical current. Resistance, measured in ohms, opposes the flow of current. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This relationship is fundamental to understanding how electrical circuits work. Circuit breakers are safety devices that protect against overloads and short circuits. When the current in a circuit exceeds the breaker's rating, the breaker trips, interrupting the flow of electricity. Extension cords should be used with caution, as they can be a source of electrical hazards if not used properly. It's important to use the correct gauge of extension cord for the intended application and to avoid overloading them. A HAL schedule is a listing of all the circuits in an electrical panel, along with the loads that they serve. This is helpful for identifying the correct breaker for a particular circuit and for troubleshooting electrical problems. A floor plan showing the location of outlets and fixtures can also be useful for electrical troubleshooting and renovation planning. When hiring an electrical contractor, it's important to choose someone who is licensed, experienced, and insured. Check their references and make sure they are familiar with the NEC and local electrical codes. The process of offering to buy a house with known electrical issues can be complex. It's important to have a clear understanding of the scope of the necessary repairs and the associated costs. Negotiating the terms of the sale to include the cost of electrical repairs can help to protect the buyer from unexpected expenses. In addition to prayers and positive energy, practical steps should be taken to ensure the safety and reliability of the electrical system. This includes hiring a qualified electrician, obtaining the necessary permits, and following all applicable codes and regulations. Electrical safety is paramount. Never attempt to work on electrical systems unless you are qualified and have the proper training and equipment. If you are unsure about anything, consult a qualified electrician. Remember to turn off the power at the main breaker before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment. Test all circuits with a voltage tester before touching any wires. Be aware of the potential hazards of electricity and take all necessary precautions to protect yourself and others. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock. They should be installed in all areas where water is present, such as bathrooms, kitchens, and outdoor outlets. Arc fault circuit interrupters, or FCIs, provide protection against arc faults, which can cause fires. They are typically installed in bedrooms and other areas where there is a high risk of fire. Surge protectors protect electronic devices from voltage spikes and surges. They should be used on computers, televisions, and other sensitive equipment. Smoke detectors and carbon monoxide detectors are essential safety devices that should be installed in every home. Test them regularly and replace the batteries as needed. Develop an emergency plan in case of an electrical fire. Know how to shut off the power to the house and have a fire extinguisher readily available. Teach family members about electrical safety and what to do in an emergency. Regularly inspect electrical cords and appliances for damage. Replace any damaged cords or appliances immediately. Avoid overloading electrical outlets and circuits. Use power strips with built-in circuit breakers to protect against overloads. Keep electrical appliances away from water. Never use electrical appliances in the bathtub or shower. Be careful when using ladders near power lines. Maintain a safe distance from overhead power lines. If you see a down power line, stay away from it and call the utility company immediately. Electricity is a powerful force that can be both beneficial and dangerous. By understanding the principles of electricity and taking the necessary precautions, you can ensure the safety and reliability of your electrical system. Let's discuss some additional technical details concerning electrical systems. Firstly, the National Electrical Code, or NEC, is updated every 3 years. It is important to consult the latest version of the NEC for the most up-to-date requirements. Secondly, electrical panels should be properly labeled to identify the circuits they serve. This makes it easier to troubleshoot problems and perform maintenance. Thirdly, electrical wiring should be properly sized for the intended load. Undersized wiring can overheat and cause a fire. Fourthly, electrical connections should be tight and secure. Loose connections can cause arcing and overheating. Fifthly, electrical boxes should be properly grounded. This provides a path for fault current to flow back to the source, tripping the circuit breaker. Sixthly, electrical work should be inspected by a qualified electrical inspector. This helps to ensure that the work is done safely and in accordance with the NEC. Seventhly, electrical maintenance should be performed regularly. This includes inspecting wiring, connections, and devices for damage and wear. Eighthly, electrical upgrades may be necessary to accommodate increased electrical loads. This is especially true for older homes that were not designed to handle modern electrical demands. Ninthly, electrical energy efficiency can be improved by using energy-efficient appliances and lighting. This can save money on electricity bills and reduce environmental impact. Tenthly, electrical safety training should be provided to employees who work with electricity. This helps to prevent accidents and injuries. Now let's delve a bit deeper into specific electrical components and their functions. We'll start with circuit breakers. Circuit breakers are designed to protect electrical circuits from overcurrents, which can be caused by overloads or short circuits. When an overcurrent occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to the wiring and appliances. There are several types of circuit breakers, including thermal-magnetic breakers, which use a bimetallic strip and an electromagnet to trip, and electronic breakers, which use electronic sensors and circuits to detect overcurrents. The interrupting rating of a circuit breaker is the maximum amount of current that the breaker can safely interrupt without being damaged. It's important to choose circuit breakers with an interrupting rating that is adequate for the potential fault current at the installation location. Next, let's consider ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electrical shock by detecting ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. When a GFCI detects a ground fault, it trips, interrupting the flow of electricity and preventing electrical shock. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or RFCIs, are designed to protect against arc faults, which are dangerous electrical discharges that can cause fires. Arc faults can occur when there is a break or weakness in the insulation of electrical wiring. When an RFCI detects an arc fault, it trips, interrupting the flow of electricity and preventing a fire. RFCIs are typically required in bedrooms and other areas where there is a high risk of fire. Now let's examine surge protectors. Surge protectors are designed to protect electronic devices from voltage surges, which are sudden increases in voltage that can damage sensitive electronic components. Voltage surges can be caused by lightning strikes, power grid switching, and other events. Surge protectors work by diverting excess voltage away from the protected devices. There are several types of surge protectors, including point-of-view surge protectors, which plug into a wall outlet, and whole-house surge protectors, which are installed at the main electrical panel. Next, let's discuss wiring. Electrical wiring is used to carry electrical current from the source to the load. There are several types of electrical wiring, including copper wire, which is the most common type, and aluminum wire, which is less expensive but also less conductive. The size of the wiring is determined by the amount of current it needs to carry. The National Electrical Code specifies the minimum wire size for different types of circuits and loads. Wiring insulation is used to protect the wiring from damage and to prevent electrical shock. There are several types of wiring insulation, including thermoplastic, thermoset, and rubber. The type of insulation is determined by the application and the environmental conditions. Let's move on to electrical boxes. Electrical boxes are used to enclose electrical connections and devices. There are several types of electrical boxes, including metal boxes, plastic boxes, and fiberglass boxes. The type of box is determined by the application and the environmental conditions. Electrical boxes must be properly grounded to provide a path for fault current to flow back to the source. Now let's consider electrical panels. Electrical panels are used to distribute electrical power to different circuits in a building. Electrical panels contain circuit breakers which protect the circuits from overcurrents. The size of the electrical panel is determined by the total electrical load of the building. Electrical panels must be properly grounded to provide a path for fault current to flow back to the source. Proper grounding is a critical safety measure in electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. There are several types of grounding systems, including equipment grounding, which grounds the metal parts of electrical equipment, and system grounding, which grounds the neutral conductor of the electrical system. The National Electrical Code specifies the requirements for grounding electrical systems. Finally, let's discuss electrical safety. Electrical safety is paramount when working with electricity. Always turn off the power at the main breaker before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment. Test all circuits with a voltage tester before touching any wires. Be aware of the potential hazards of electricity and take all necessary precautions to protect yourself and others. If you are unsure about anything, consult a qualified electrician. It is crucial to understand the potential dangers of electricity and to follow safe work practices at all times.